Hello and welcome to the maths class. This is teacher Swati and we are studying shapes and geometric reasoning. In our previous video, we learned about corresponding angles and corresponding sides. In this video, we are going to learn about identifying symmetry of 2D shapes and classifying quadrilaterals. So let's get started. Identifying symmetry of 2D shapes. The symmetry of 2D shapes is of two types, line symmetry and rotational symmetry. Line symmetry, as the name suggests, is about a line itself, a line that divides a shape into two equal halves, two identical halves. And rotational symmetry is something where a shape, if you rotate it any number of times, gives you the same look as it was in the first stage. So that is known as rotational symmetry, and rotational symmetry is always written in the order. That means how many times you rotate it to get the similar look. Now here a rectangle is seen in line symmetry. This rectangle has two lines of symmetry. One of the lines of symmetry is horizontal and the other vertical. You can use dashed lines to show lines of symmetry on a shape. If you fold a shape along its lines of symmetry, one half of the shape will fit exactly on top of the other half. Now the rotational symmetry. This rectangle has a rotational symmetry of order 2. Now you can see over here, the vertices of this rectangle are denoted by some numbers, that is 1, 2, 3 and 4. If you flip it out or rotate it in such a way that this 1 comes in this place over here, then you can see it looks similar as it was in the previous diagram. So first is this position and second is this position. So two positions we get of similar looks. The order of rotational symmetry is the number of times a shape looks the same as it is rotated through one full turn. So order of rotational symmetry for a rectangle is 2. Now we are moving on to classifying quadrilaterals. Now we know the names of many quadrilaterals like square, rectangle, trapezium, parallelogram, but we are going to study this in details with all the properties. Now here in front of us is a square. A square has all sides same. There are two pairs of parallel sides, the opposite ones. And all the angles of a square are 90 degrees. The diagonals bisect at 90 degrees. Here diagonals are not shown. Let me show this to you. It's not quite a straight line, but still I'm trying to make it. Yeah, the diagonals bisect at 90 degrees and there are 4 lines of symmetry. The diagonals also can be considered as the lines of symmetry, 2 diagonals, and then we can divide the same this way, vertical and horizontal. So there are 4 lines of symmetry. The order of rotational symmetry is 4. If you are turning this or rotating the side, this is your first one, this side from here to here. Then again from here to here, second rotation, third rotation, and then the fourth rotation. So in this manner, you get the order of rotational symmetry as 4. Now, this is again a quadrilateral 4-sided figure, a rectangle. A rectangle has 2 pairs of equal sides. Only 2 pairs of equal sides, opposite ones, and 2 pairs of parallel sides. All the angles are 90 degrees. The diagonals just bisect. In the square, we saw that they bisect at 90 degree, but here they just bisect. That means they cross each other through their midpoints. There are two lines of symmetry only, and the order of rotational symmetry is 2. Next, we have a rhombus in front of us. A rhombus is, you can say, quite similar to a square. Like it has all the sides same, two pairs of parallel sides, opposite angles are equal, diagonals bisect at 90 degree, two lines of symmetry, and order of rotational symmetry 2. Only difference between a square and a rhombus is that here it is in the rhombus it is written as opposite angles are equal, whereas in square they say that all the angles are 90 degree. Rest of all the properties are same. Next we have a parallelogram. A parallelogram again is a four-sided figure. As the name suggests, parallelogram, two pairs of the sides are of equal length and two pairs of the sides are parallel, so it is a parallelogram. Opposite angles are equal, all are not same, only opposite angles are same. Diagonals bisect each other, that means they are crossing each other through their midpoints, and there is no line of symmetry over here, but the order of rotational symmetry is 2. Next shape that we are having in front of us, or the next quadrilateral that we are having, is a kite. We all know the shape of a kite. Here two pair of equal sides are present, and the equal sides are not opposite ones but the adjacent ones. So here you can say this side ED is equal to DG and EF is equal to GF. Yes, and there are no parallel sides, one pair of equal angle is present, and only one diagonal is bisecting the other one. You can see this diagonal over here is quite longer one, and the another one over here, the shorter one, EG. EG, you can see EG is been bisected by DF. Diagonals cross at 90 degrees is another property, and one line of symmetry is present, vertical line of symmetry, and the order 1 rotational symmetry is present over here. Next we have trapezium. Now trapezium again is a quadrilateral where two sides are of same length and one pair of parallel sides. Only one pair is parallel, like AB is parallel to DC, but AD and BC are not parallel. Two pairs of equal angles are also present. You can consider angle A and angle B of same measure, and angle D and angle C of same measure. And there is only one line of symmetry you can consider from that is passing from the between of it, and the order of rotational symmetry is 1. You have to rotate it completely to get the previous shape. So the order of rotational symmetry is 1. Thank you.